Here we get to begin section 5.3, and let's see. Section 5.3 is the graph of a rational function. Now we've looked somewhat at the graph, but this chapter is, or this section is specifically looking at how can we create those particular graphs. But in order to graph, one of the things that we need to be very concerned with is the domain. So let's begin with, how do we find the domain? Well, once again, the domain on a rational function, all that is really important is that denominator. So in number 1, the denominator is x squared minus 16. I'm going to set it equal to 0 to find out what values do I need to exclude. Add 16. And take the square root of both sides so that x equals either positive or negative 4. So the domain here would equal from negative infinity all the way up to negative 4, between negative 4 and 4, and then 4 to infinity. Likewise for number 2, once again, we need to be concerned with 5x squared minus 3x minus 8, setting that equal to 0. And I look, okay, I can factor this relatively easily. 5x minus 8 and x plus 1. Set each one of those equal to 0. 5x minus 8 equals 0. Add 8. And divide by 5 so that x equals 8/5, or setting x plus 1 equal to 0, subtracting 1 from both sides so that x equals negative 1. And so the domain falls out pretty much from negative infinity to negative 1. Then it's going to go from negative 1 to 8/5, and then from 8/5 to infinity. So there is the domain. Three through 8, leading up, realize we're looking to try and graph things. We're looking at intercepts, and 3 through 8 basically asks, can we get x-intercepts and or y-intercepts of particular functions? And that's where we are going with these particular problems. And so, number 3, we need to find the y-intercept of that function. Well, the y-intercept is pretty simple. Let x equal 0. So that would be 12 times 0 over 0 squared minus 19, or 0 over negative 19, which equals 0. So the y-intercept would be 0, 0. Simple enough. Number 4, the y-intercept. Hey, fairly simple. All we need to do is let x equal 0. So let's see what we get here. Not quite so simple, but it's not too bad. 23 over 0 plus 20, and 0 squared minus 5. So this will equal 20 times 0 minus 5 down in the denominator, and 23 in the numerator. This becomes 20 times negative 5, and 23 up there, and so this becomes negative 23 over 100 when it's all said and done. So the intercept would be 0, negative 23 100ths. Number 5, y-intercept one more time, then we'll get into x-intercepts. So it's just a matter of plugging in the 0 into f. 0 squared minus 10 times 0 plus 2 all over 5 times 0. Oh, slight problem. 2 over 0, which says there's no solution here. So that means there is none. There are no y-intercepts. There's not a y-intercept on this particular problem. Six, 7, and 8 ask for the x-intercepts. That requires a little bit more work because it's just not simple substitution. It's substitute in and then solving. So number 6, we're going to let 0 equals 2x plus 3 over x minus 6. But the really nice thing about it is the only time this equals 0 is when the numerator does. So that means 2x plus 3 equals 0. Subtract 3 and divide by 2, so x equals negative 3 halves. So that means negative 3 halves 0 would be the x-intercept. Let's look at number 7. The only time, if we always remember, the only time that there's an x-intercept is when the numerator equals 0. So number 7, 0 equals 5. Ooh, that can't happen. So there is no x-intercept. And number 8, once again, it can only equal 0 when the numerator does. So x minus 3 times 2x plus 5. So I need to put x minus 3 equals 0, or x equals 3. 2x plus 5 equals 0. Subtract 5, or divide by 2, and divide by 2. And so that would mean 3, 0, and negative 5 halves 0 would also work. Now the next group actually wants us to sort of bring all these together and think about asymptotes and stuff like that in order to actually graph these functions. And so let's take a look at number 9. Number 9, f of x equals x plus 1 over x. But in order to use all this stuff that we've been doing is we need to get it into a rational function, which means some algebraic expression over another algebraic expression. In other words, we need a common denominator. And the common denominator here would be x, and all we have to do is multiply that by x, so we get x squared plus 1 over x. So this is what we're going to use in order to do whatever we need to do. Okay, let's look at horizontal asymptotes. Okay, I'm going to put my graph over here. Well, no, we want to start out with vertical. Oh man, that was bad. I want to look at our vertical asymptotes. Vertical asymptotes only occur when this is equal to 0. Well, x equals 0. There's an asymptote. Our y-axis is our asymptote, so we know it shouldn't cross this axis whatsoever. Now, as far as the horizontal or oblique, okay, I look. My numerator has a power of 2. Denominator has a power of 1, or degree of 1. Okay, so my numerator is 1 more than the power of my denominator. That means I need to take y equals and then take x squared over x and simplify that, because I take just this first term over this first term. And so I see that those simply cross out, so y equals x. And y equals x is the one that is slanted, you know, it cuts the first and third quadrants exactly in half and stuff like that. Okay, and then, so we've got that. And then it's just a matter of, let's plug in a point and see what we get. So, because we know it's not going to get close, or it's going to get closer and closer to 0, and it's never going to cross this either. And once we see where it's going to go, we have to realize what it's going to look like. So I'm going to pick the point 1. If I pick point 1, I get 1 squared plus 1, well, that's 2 over 1. or 2. So that's going to be, somewhere about right there. So I know it's in this section. It's never going to cross here. It's never going to cross this. It's never going to cross this. But I do know that it's going to look something like this. It's going to come along, it's going to curve around, and then it's going to go off in that direction forever. Now, generally speaking, and in fact, since it's in this section here, it's also going to be in this section here. But how would we know that? Well, let's plug in -1 into this equation right here. -1 squared is still 1. 1 plus 1 is 2, and 2 over -1 is -2. So that puts us down here in this area. So it's going to put us back into this little area. It's never going to cross this. It's never going to cross this. So I'm going to try as best as I can, get closer and closer to that, curve around here, and then come back closer and closer to the y-axis. And there is the graph of x plus 1 over x.